All right, wow, dude. This is so fucking funny because I thought we dismissed this a long time ago. But let's go ahead and get back to it. Let's see what this motherfucker has to say.
Consider a sum that looks like this. 1 plus 2 plus 3 plus 4 plus and so on. And this, like the other ones we've seen, is certainly not converging. You're adding numbers that increments are bigger and bigger. So
Not converging means it's infinity, dude. But watch this Korean motherfucker. He goes to all lengths of the goddamn spectrum. Let's have some fun.
But they're not kind of converging to some specific target. Nevertheless, it's actually interesting to think about when we have this expression, if we were to assign to it some numeric value, what would that value be? And then at the end also, how can we justify it? How are we going to analyze this? So I'm going to do something which is mathematical doodling, where we're going to do some operations.
Notice what he said. He's telling on himself, mathematical doodling.
We're going to not worry so much, at first at least, that we're breaking some rules like assigning this a numeric value. And then we're going to try and justify the inclusion later. If I look at this thing here, suppose I contemplate negative 4x. So I can calculate what this is, but I want to position it in a certain way. So I'm going to think of it as negative 4 times this 1, and then I have to add negative 4 times this 2, but I'm going to put that over here. So I'm sort of...
Wait a minute. He's like, hold on, I'm gonna need to move shit around. Really? Come on, man. Why are you moving shit around, bro? Hold on, let me go back a little bit. Can I go back a little bit?
Calculate what this is, but I want to position it in a certain way. So I'm going to think of it as negative 4 times this 1, and then I have to add negative 4 times this 2.
What?
But I'm going to put that over here. So I'm sort of doing things in steps of 2.
Wait a minute. What happened to the negative 4? What happened to negative 4 times the 1? Wait a minute. What the fuck is this guy doing?
A slightly more complicated example, which is related to things that mathematicians these days care a lot about, and it also has some historical significance. So I'm going to consider a sum that looks like this. 1 plus 2 plus 3 plus 4 plus and so on. And this, like the other ones we've seen, is certainly not converging. You're adding numbers that increments are bigger and bigger, so they're not kind of converging to some specific target. Nevertheless, it's actually interesting to think about when we have this expression, if we were to assign to it some numeric value, what would that value be? And then at the end also, how can we justify it? How are we going to analyze this? So I'm going to do something which is mathematical doodling, where we're going to do some operations. We're going to not worry so much, at first at least, that we're breaking some rules like assigning.
We're not going to worry about breaking rules. Hey, man, we might as well make 2 plus 2 equal 5.
This numeric value. And then we're going to try and justify the inclusion later.
See,
if I look at
nerds,
this thing
man,
here, suppose I contemplate negative 4x. So I can calculate what this is, but I want to position it in a certain way. So I'm going to think of it as negative 4 times this 1, and then I have to add negative 4 times this 2. But I'm going to put that over here. So I'm sort of doing things in steps of 2 here. So minus 12 and so on.
No. Ask yourself, how does this make any fucking sense? You're only doing it for... I don't even get it. Why are you only...
And the point of it writing it this way is that now if I add the x and the negative 4x, on one side I'm going to get, of course, negative 3x. And then the other side I'm going to get 1 minus 2 plus 3 minus 4, and so on. So it'll be the kind of alternating sign version of the original x. Now I'm going to do something kind of similar again, where I just say, well, negative 3x is, and now I'm going to shift the positioning by 1. So it's like 1 minus 2 plus 3 minus 4, and so on. So I'm writing the same expression, but just shift.
Now, if you can't see that there's games being played here, then I don't know what to tell you.
Did over by 1. And the reason I did that is because then I'm going to add these things, and I'm going to get negative 6x, and it's going to be equal to this 1 minus 1 plus 1.
Shit, I can prove 2 plus 2 equals 5 quicker than this motherfucker is trying to do this shit.
Minus 1.
Ask me to do it, I'll do it.
Did you break any rules by doing that little shift, moving them over? That was just for visual reasons, wasn't it? That was just to help.
Yeah. The shifting, it shouldn't do anything, right? Because it's the same expression. I mean, the adding and subtract the positioning doesn't really matter. Of course, I broke rules when I wrote the equal sign, and I was treating x as a number. So this is all on kind of shaky grounds. But this is the kind of doodling which was done by a mathematician from the 1700s named Euler. And it turns out that it does produce the correct conclusion. So it's kind of interesting. But we have to, of course, in math, we have to go back and justify, like, why is it okay?
All right, so minus 6x gives us something we're familiar with. You showed us this earlier.
We saw that, yeah.
Now I want you to look at what kind of paper this nigger's writing on. Looks like he's writing on scrolls.
Exactly. We saw it earlier. We saw that this is 1/2. And so the conclusion is that x is actually negative 1 over 12.
Yeah. Sold. Except for that naughty thing at the start.
Right. So what does this kind of conclusion actually mean? How does it justify it, and sort of what is the significance of that?
Paper change. Wow. Let's get a better nerd to try to explain this bullshit. You add up all the numbers, all the natural numbers, and the sequence, the sum of that sequence is negative 112. Yeah, totally cool.
So
Love it, man.
Earlier on, we were talking about this function 1 plus r squared plus r cubed and so on as a function of r. And then we said, wait, as a function of r, it's equal to 1 over 1 minus r, at least when r is...
Hey, quick, somebody go look up, what is it called? A quick change scam. Hey, I'll give you $1. No, give me back the $10. I'll give you $5.
Less than 1 in absolute value. And then it's 1 over 1 minus r, actually... That has fewer restrictions on what you can plug in for r. You can plug in any r that's not equal to 1. You get a sensible answer. So similarly here, there's this thing called the Riemann zeta function. So it's a function of a variable.
Can we get this kid some pussy? Can we get this... Dude, can we get this kid a piece of ass?
S, and it's
He probably don't even
1 over 1 to the s plus 1 over 2 to the s, plus 1 over 3 to the s, plus 1 over 4 to the s, and so on. So you're going to see every positive counting number here. So the way we would write this in shorthand is sum over all n of 1 over n to the s. We need to ask ourselves, like, where does this expression actually make sense? And it's only going to make sense when s is big enough, because you need to make sure that you're adding very, very small increments in order to get this quantity to kind of converge to a fixed value. So it turns out that this is okay if s is bigger than 1. Mathematicians care about this Riemann zeta function because its properties are actually closely intertwined with the distribution of prime numbers. So if you've heard of the Riemann hypothesis, one of the kind of longest outstanding conjectures in mathematics.
Actually, I've heard of that, and I actually know it's true. I know why it's true. I just can't rigorously prove it. So, because I can't, who cares? But maybe this nerd will. Because he's already like 3/4 of the way there. He just doesn't fucking know it. Negative 112. Man, come on, dude. Shouldn't that tell you something? When you get that as the sum, shouldn't that tell you something of what's really going on? No. Oh, these fuckers, man. Sometimes I wonder what's wrong with these people. I'm not going to finish playing out this on this video. I'm just like, yeah, they resurrected the fucking negative 112. I can prove that 2 plus 2 equals 5 easily. You're like, well, how can you do that? Well, all right. Take 2.3, right? 2.3. Now add 2.3 to 2.3. What do you get? You get 4.6. Now look at the entire equation and rounding. By the rules of rounding. Now see, you're going to understand something now when I say this. Is that the rules of rounding are rules and they're arbitrary. So 2.3 rounds to 2. 2.3 also rounds to 2. So you have 2 plus 2 equals 4.6, which rounds to 5. So now you have 2 plus 2 equals 5. You see how easy that was? It didn't take me this long, and I didn't have to fucking put anything on the goddamn blackboard. You want to know why the Riemann hypothesis is true? The Riemann hypothesis is true. It's because of the exponent. It has to be negative 1/2. Because that's the square root. But we don't need to get into that. I can't prove it rigorously, but I know that's why it's true, and I know it's true. Anywho, you know what I'm saying?